Good.
Good day.
Oh.
In this video, we're going to talk about file system interface on operating system.
Coverage for the file system interface are access methods, directory structure, file system mounting, file sharing, and protection.
The objectives of the file system interfaces are to explain the functions, its functions, then describe the interfaces, and then explore the protection of the file system, and includes to discuss the file system design trade-offs like access method, file sharing, and directory structure.
The file system is the structure in which all the information on your computer is stored. Nearly everything that has an identity on your system, data, commands, symbolic links, devices, and directories, are represented as items on the file.
A file system cannot be a file system without a file. A file is a named collection of related information that is recorded in a secondary storage. They can be programs, which can be source or objects, or data files. Data files may be numeric, alphabetic, alphanumeric, or binary. Examples of files can be documents, songs, videos, or anything that can be accessed in a graphical interface system, which acts like a customer number on a restaurant table. File types are also known as file extensions. Examples of these are .txt for text files and .mp4 for video files. Directories are locations where the files can be found. An example of it is shown below. Storage capacity is occupied depending on the size of each file. An example here is shown on the right, where the blue piece indicates the used space on the disk and the magenta piece to be the free space of the disk. One must provide privileges in accessing files depending on an individual user or a group. Otherwise, one might disrupt some important files that run the system. Time, date, and user identification contains information used for monitoring and protection of the file. Files are structured according to its use. It could be a simple record structure or a complex record structure, depending on the data being stored, with the latter requiring to have a proper allocation command attributes. The complex record structure could initialize the first two structures.
Sequential access method. Sequential access method is a file access method wherein accessing the file contents is on by a sequence. First part of the file, second, and so on and so forth. The best example of this are program compilers, wherein compilers must access each lines of the code in order to run the program. So, direct access method. Unlike the sequential access method, direct access method access file components directly where it resides in the file. The best example of this are databases, wherein you could directly access a column from a directly accessed table.
To tackle or discuss the directory structure and its meaning. Okay, so we will give the meaning of directory structure is, or simplify it, is a node containing information about all files. Okay, so we will use a linked list or linked node to illustrate or to understand it well. So these are nodes that represents the directory structure. Okay, so every node represents a directory that contains information. So every node will link it to an information or a file. So that's the basic or the simplest understanding that we will give in the directory structure. Okay? Hello? So we will tackle about the operations of directory structure. First, search for a file. Very basic. We'll search files in a specific directory. Next is create a file or directory. Okay, so it will from a create a new directory or a folder to put new files in it. Okay, next is delete a file or a directory. From deleting a directory, it will also delete its files, all files and all subdirectories in that particular directory or folder. Okay, next, rename a file or a directory. From renaming a file or a directory, it will not rename also the directories, there's the subdirectories that in that directory. Okay? Next is list a directory. It will literally sort all the directories from A to Z, or from numeric A to Z, or numeric 1 to 9. Single level directory is the most simplest directory in operating system. Right? All users will use a single directory to store all their files in that directory, or contains all their files in a directory. So this represents a single directory illustration. Okay, the problem of single level directory is that if A has an old file that been stored in a directory, then B will create a file, then name it and name that file A. Then the old A file will be overwritten by the new file B, which is created by user B. Two-level directory is the enhancement of one-level directory, which all users have their own directories to be used as their container as of their files.
Tree structured directory. It is a tree-based directory. The directory themselves are files. This leads to the possibility of having directories that contains files and subdirectories. Second, it is an extension of two-level directory. While all users have their own directory and independently isolated from other users' files. This represents a tree-structured directory. Okay, so directories have subdirectories in it and holds file, and subdirectories then holds files. Thank you. Acyclic graph directory is an extension of tree-structured directory. Files and directories starting from fixed directory are owned by one particular user. In acyclic structure, this prohibition is taken out, and thus a directory or file under directory can be owned by several users. Unix provides two types of links for implementing acyclic graph structure. First, hard link involve multiple directory entries that both refers to the same file. Hard links are only valid for ordinary files in the same file system. Second, symbolic link or soft link involve a special file containing information about where to find the link file. Symbolic link may be used to link the directories and or files in the file system, as well as files in the current system. General graph directory. If cycles are allowed in the graph, then several problems can arise. First, sub-tree can become disconnected from the rest of the tree and still not have the reference count reduced to zero. Periodic garbage collection is required to detect and resolve this problem. Check disk and disk operating system search for this problem. Among others, even though cycles are not supposed to be allowed in either system, disconnected disk blocks are not marked as free, are added back to the file system with made-up file name and can usually be safely deleted. Second, search algorithm can go into infinite loop. One solution is not follow link in search algorithm, or not to follow symbolic links, and only allow symbolic links to refer to directories.
So file mounting. File mounting always takes place if new volume is added to your system. So basically, a file mounting is just an update of the current system directory for the new volumes directory to be added and in order for the files to be accessed. So why does we need to update those directories, I mean? Because files must be mounted first in order for the system directory to access it.
To illustrate mounting, we have these two figures. The yellow figure represents the system directory and the green one is the unknown directory for the system. Let's say we want to access a file on the green figure. To do that, the green directory must be mounted to the system. Operating systems handle this by setting a specific directory to accept directories to be mounted. The to be mounted directory connects to it, and then the system directory updates. After the update, the unmounted directory becomes a part of the system directory. The system can now access files from it. Various operating systems implements it in different ways. Linux uses the /mnt/directory to accept mounting of new partitions. Then in Windows, new drive root directory is created. It is commonly known as the volume letters like C or D directory and
File sharing. People wants to share their files. Why do you think Facebook become very popular and the owner of it are very rich? Then there are many types or methods of file sharing.
files can be shared in different ways. You can copy it in an external storage then share it to others, or you can share it through a network. Sharing through transferring files from one system to another using an external storage can give large hassles among users, while sharing through network doesn't, making it the best way to share files. Sharing through network always done by multiple users. Users are managed by adding specific permissions to them. Permissions could be added in a single user where permissions only apply to the user itself, or it could be added to a group of users which permissions are added to the group and users which are members of it will be granted with the group's permission regarding on what permission that each of the members have. Users have specific user ID and groups have specific group ID. File sharing on networks works by mounting the shared file system of the remote system to your current system for you to access it. Operating system implements it by using a specific directory to be the only part of the system which could be accessed by other systems remotely. Files are shared on a network in two different ways. Suppose computer 3 will access a file on computer 1. 3 will send a request to 1 and then it will mount 1's shared directory to it. In this scenario, 1 becomes the server and 3 becomes the client. A server could accommodate multiple clients, and a client could connect to different servers, depending on how operating system implements it. The second method is through distributive method. The source of the file distributed copies of the file to the network. Any system that is connected to the network could access the copies. Copies of the file are composed by the file itself, and the data that contains information of the system that could only mount the file for it to be accessed. If the data corresponds to the system, the file will be mounted. If not, then there will be no mounting to occur. Mounting the shared directory to your system directory doesn't mean that the file is now in your storage. It is still on the source storage and other system might access and override it even you're trying to do something on it. Operating system deals with this scenario using consistency semantics. Consistency semantics specifies how multiple users are to access a shared file simultaneously. One of it is the Unix file system. In UFS, you can see the other users who are accessing the file that you're currently accessing in the shared directory. Each user will be given a file pointer of the file that they're currently accessing. The part of the file that the currently overwritten by a user will be inaccessible for other user until the operation is finished. For example, let's say all users wants to access this part of the file, but this user was the first to write on it. The other user must wait until the part of the file will be available for them to do. The other one is the undo file system. In AFS, users that are currently accessing the same file will be given a copy of the file. They can overwrite anything in the copy, but the overwriting of the primary file will only take place if no user is conducting an operation to it. If there is an operation in the file, you must wait until the operation is finished. Then, it's your turn. Although sharing of files in a network is a good method, there could be some failures that could happen. Failures could occur when a network connection was lost or the source system of the file was shut down. Failure could lose data, so recovery must be implemented. Operating system used two recovery methods. The first recovery method involves the system state. During a file access, if the source system or the requesting system suddenly shuts down, any operations will be interrupted. In this recovery method, the states of the source system and the requesting system is being monitored. If one of them is down, the operation will be paused and wait for the system to be available again. If the down system is available again, operation resumes. In this method is only slower to recover and prone to data loss if the down system will not be able to be available in a given time. The second is all data about the access is with each request. The data information is packed and travel together with the request itself. There's no more time to wait in this recovery method, making it a good way to recover, but security is not safe in this method because of the fact that all data about the request is with the request itself. Protection. Protecting a file is a common thing to do in creating it. It always involves an owner of the file, a user of the file, and a group of files. The owner of the file is the one who created the file, and the one always responsible to grant access operation permissions to a user or a group of users. Operations can alter the file. The owner decides whether all or few of these operations should be given to a user or a group. A group could be a special group which members are picked by someone. Could be the owner of the file, which would give permissions to the group, or the general group, or the group whose members are not a member of a special group. It doesn't mean that if a user is a member of the general group, then the user is not a member of any special groups at all. Permission of this group is also set by the file owner. Let's rate the draft. Let's say these are users. Users are picked to be a member of a group. All users that became a member of the group will be granted permission set. The ones that are not chosen will become the member of the general group, which privileges are still set with the owners. The best example for this is a published book. The book is the file, the author would be the owner, the publishing house staff are the members of the special group, and the readers are the member of the general group. This is a group of user and access type window in Windows. In this area is the list groups of users. And in this area is where to set permissions to every group. This figure shows an access table in Linux. The first column are the permissions, then the number of links to the file, then the owner's name, then the group's name, then the size of the file in bytes, then the date of the last modification, and finally the file's name, could be with optional extensions.